Earth Systems 3209, Unit 5, Earth's Resources. Reference for this unit can be found in a textbook in Chapter 21 and Appendix A and B in the Curriculum Guide. Unit 5, Topic 1.1. We'll look at economic minerals and economic deposits. The focus of this presentation will focus on defining economic minerals and economic ore. We'll focus on identifying factors which determine if a mineral is of economic value, and we'll also focus on identifying and describing the different types of mineral deposits. Let's first look at terminology associated with economic minerals. An economic mineral is a mineral that is extracted, processed, and marketed at a profit. Factors that determine if a mineral is economic value will be the interest in the mineral, the size of the deposit, the mineral concentration, mineral depth below the surface, and the market value of the mineral. Minerals are usually focused or concentrated in what's called an ore deposit. An ore is a natural material with a high concentration of economically valuable minerals that can be mined at a profit. References for these topics can be found in the textbook on page 583. When we look at economic minerals, we first need to understand the origin of these mineral deposits. A mineral deposit is a volume of rock enriched in one or more minerals. In this sense, a mineral refers to the useful material, a definition that is different from the way we defined a mineral earlier in the course. Earlier in the course, in Unit 3, when we looked at minerals, we defined a mineral as a naturally occurring inorganic solid with a definite chemical composition and molecular structure. In this respect, when we look at economic value of minerals, we will look at it in a different way. Mineral deposits can be classified on the basis of the mechanism responsible for concentrating the valuable substance. Examples include, number 1, magmatic mineral deposits, number 2, hydrothermal mineral deposits, number 3, sedimentary mineral deposits, number 4, placer mineral deposits, and number 5, metamorphic deposits. We will now go and look at 5 of these different types of mineral deposits in detail. And references on mineral deposits can be found in your textbook, starting on page 583 and continuing to page 596. The first mineral deposit we will focus on is one that concentrates metals, and these deposits are called magmatic deposits. A magmatic deposit shows accumulations of metals associated with magma forms from igneous rocks. Certain metals are enriched in certain magmas and further concentrated during the cooling of the magma. As minerals crystallize from magma body, heavy minerals may sink to the bottom of the magma chamber and others form on the sides of the magma chamber. If we look at the diagram to the right, we will see a representation of a magma chamber where we have rectangular crystals settling to the bottom of the chamber. In addition to the crystals forming on the bottom of the magma chamber, some of these crystals which form from the magma can also form down along the sides of the magma chamber. When we look at magmatic deposits, 2 main deposits usually form from magma chambers. The first is called a layered deposit. Through a layered deposit, gravitational settling is the main force that causes the crystals to settle to the bottom. So through gravitational settling, heavy minerals that crystallize early settle and concentrate on the bottom of the magma chamber. This results in what's called a layered deposit. So in your diagram below, again, we see the heavier, more dense crystals, such as minerals found rich in platinum, minerals rich in nickel, and in this case it will be Voisey's Bay, where we get the nickel deposits. The high-density minerals sink to the bottom of the magma chamber, forming a layered deposit. In comparison, we can also get what's called a disseminated deposit, and these also form as a result of magmatic deposits. In a disseminated deposit is a mineral deposit in which the metal is evenly distributed in generally lower concentrations throughout the large masses of igneous rock. Some examples include porphyry copper deposits and nickel deposits. Nickel deposits are evident in Sudbury, Ontario, and Voisey's Bay in Newfoundland, Labrador. In the diagram to the right, we see a sample of a nickel-bearing rock from Sudbury. And here you can see the gray areas, which will be the mineral that's high in concentration of nickel, and it's distributed throughout the rock. So this would be an example of a disseminated mineral deposit. The second type of deposit that forms metallic mineral deposits is called a hydrothermal mineral deposit. Here, minerals are concentrated by hot fluids flowing through fractures or pore spaces in rock. Hydrothermal deposits are produced when the groundwater circulates down to depths, and it heats up either by coming near the hot igneous body or by circulating to great depths within the earth, which naturally heats the water up. Such hot water can dissolve valuable minerals as it passes through large volumes of rock. As the hot water moves into cooler areas of the crust, the dissolved minerals are precipitated and deposited from the hot water solution. If the cooling takes place rapidly, in open fractures or upon reaching cool surface waters, then precipitation will take place over a limited area, resulting in a higher concentration of minerals than was originally present in the rock. An example of this type of deposit is called a vein deposit. In the diagram to the right, we see that as water passes down through the earth and it approaches near an igneous rock unit or a magma chamber, the water will heat up. As the water heats up, it dissolves minerals. This hot water then will migrate upward, away from the magma chamber, and again move towards the Earth's surface. As it moves through cracks or pore spaces or fractures in the Earth, the minerals in this hot water, as it cools, will precipitate. And once the cooling water precipitates the minerals that it is carrying, they can form concentrated vein deposits, as we see here outlined in black. So in this diagram, we see ore minerals depositing in veins, which are fractures or cracks within the Earth's surface. Hydrothermal mineral deposits are also seen beneath the oceans, associated with divergent boundaries, where we see black smokers. So along a divergent boundary, we see a magnified area here on top, where we see the cold ocean water moving down through cracks in the ocean floor, generally normal faults. This water warms as it gets closer to the magma, dissolves metals, and as it moves or migrates back to the surface, they precipitate the minerals in fractures, forming again hydrothermal mineral deposits in veins, or can be widespread throughout the magma that flows onto the ocean floor and would then become disseminated mineral deposits. So note, in the diagram to the right, both vein deposits and disseminated deposits are seen